purpose of this video is to help us to see how we can apply the unit circle to solving specific problems where we're asked to find an exact value without using a calculator. Of course, this is going to require us to know some things about where certain angles are located on the unit circle, as well as techniques that we can use to find the values for each point on the unit circle. So let's review the unit circle a little bit. If you notice, there's a lot of repetition on the unit circle. But what we want is to take advantage of that and maybe a couple of patterns that we notice so that we can really fully memorize this and not have to draw the unit circle every time we need to evaluate some special angle. And the techniques that we're using here are techniques or patterns observable simply on the special angle. So don't try this on something that's not on this particular unit circle. Okay, so the first thing that we notice is that we have in the first quadrant 0, 30, 45, 60, and 90. What if we notice here there are 5 of them? So 1, 2, 3, 4, 5. There are 5 of these. So let's say that we associated each one with a particular finger. So let's say we made 0 the pinky. Let's say we made 30 the ring finger. Let's say we made 45 the middle finger. Let's say we made 60 the pointer finger. And let's say we made 90 the thumb. So what would that look like? Well, it would look like this. We'd have 0, 30, 45, 60, 90. So again, 0, 30, 45, 60, 90. So what does that mean for the unit circle? Let's say that we took the finger associated with 30 and we folded that down. What do you notice? We have 3 and we have 1. So let's compare that to what's happening at 30 on the unit circle. So at 30, we have in the numerator of our point 3 and we have 1. Of course, we have a square root over it. We'd have to remember that, but basically 3 and 1. What if we folded down the middle finger? So we fold down that middle finger and we have 2 and then 2. So again, in that same order, that's what we have on the unit circle. We have 2 and 2. Again, we have square roots, but that's really just something that we have to remember when we put everything back down for the values. Finally, let's say we pointed using the pointer finger. So here's the pointer finger. So this is 60 degrees. If we fold down the 60-degree finger, and let's say that we wanted to find out how that connects, we have 1 and we have 3. So we have 1 and 3. So notice what happens on the unit circle. We have 1 and we have 3. So we can again begin to start using these techniques to memorize things on the unit circle. So let's say I asked you, for example, what the cosine of 30 degrees is. Well, you say, okay, well, 0, 30, 45, 60, 90. Okay, well, you fold down the 30 finger, and we know that it's 3 and 1. So we just have to remember the square root. So we have a square root. We are always going to pretty much have 2 in the denominator. So if I have 3 and 1, remember the cosine comes first in our ordered pair. Cosine is first. So I'm going to look at my hand and I have 3 as my first value. So that means that the cosine of 30 degrees is going to be square root of 3 over 2. Let's say we tried it on something else. Let's say we tried 60. So 0, so 0, 30, 45, 60, 90. So if we folded on that 60 finger, that's what it would look like. So notice that we have 1 and then we have 3. cosine comes before sine. So if I wanted cosine of 60, cosine of 60 degrees, my denominator I know is going to be 2. I know I'm going to have a square root. I'm going to put that 1 inside, but you're saying, hold on a second, square root? On the unit circle, there's no square root here. Remember that square root of 1 is 1, so this is pretty much just 1/2. So a quick way to remember it is if you are using the hand technique here and you have 1, don't even bother writing the square root because the square root of 1 is 1. But if you have 3, you're going to say square root of 3 over 2. Or if you have 2, you're going to say square root of 2 over 2. Or square root of 2 over 2. So basically, that's a technique that we can use so we don't have to draw the unit circle every time. So how can we use this technique to help us with something like cosine of 150 degrees? Well, one of the things that we also need to remember is how the points are situated within a coordinate plane. In the first quadrant, both the x and the y are positive. In the second quadrant, the x is negative, but the y is positive. In the third quadrant, they're both negative. And in the fourth quadrant, the x is positive, but the y is negative. That's basically just how we graph points. So if we had to find the cosine of 150 degrees, first of all, what quadrant would 150 degrees fall in? Well, we'd have to go past 90 before we get to 180, so this is where 150 degrees would stop. So in this quadrant, we know that the x values are negative, the y values are positive, and because cosine comes first on the unit circle, on this side, cosine is going to have a negative answer, and sine is going to have a positive answer. So if I wanted the cosine of 150, keep in mind that, again, 150 is that angle, and if we drew the reference triangle, that's the reference triangle. This small angle here, let me use a different color. This small angle here represents our reference angle. How much would that reference angle be? Well, that reference angle is 30 degrees. So it's a 30-degree reference angle. So what would that mean for us? Well, if we had 30 degrees and I said find the cosine of 30 degrees, how would you do that? So remember the fingers. 0, 30, 45, 60, 90. So again, 0, 30, 45, 60, 90. So we'd fold down the 30 finger and we'd have 3 and 1. So 3 first, then 1. So the point would have to be square root of 3 over 2 and then 1/2. Remember that cosine comes first and sine comes next. So in other words, we're saying that the cosine of 30 degrees is radical 3 over 2, whereas the sine of 30 degrees is 1/2. Keep in mind though, this is 30 degrees, and 30 degrees is in that first quadrant. If we had the same reference angle, like we do here, in quadrant 2, remember that in quadrant 2, our points are negative and then positive. So for 150 degrees, because it has the same reference angle, we're going to put the same numbers, radical 3 over 2 and 1/2, but because it's in the second quadrant, we're going to make the first number negative and we're going to keep the second one positive. So what does that tell us? Well, it tells us that the cosine of 150 degrees, our first value, is negative radical 3 over 2. So this one might seem like it's tricky, but it's actually not that bad. This is the cosecant. So we talked about this before. There were some relationships that we know. For example, if I know that sine is opposite over hypotenuse, and if I know that cosine is adjacent over hypotenuse, and I know that tangent is opposite over adjacent, there are reciprocal functions that we can use. So the reciprocal of sine is the cosecant. So cosecant would be hypotenuse over opposite. Cosine has a reciprocal. That's called the secant. For secant, it would be hypotenuse over adjacent. So we're just flipping the fraction basically. And for tangent, the reciprocal is the cotangent. So if tangent is opposite over adjacent, then cotangent is adjacent over opposite. So let's see how we can use this to help us work out what the cosecant of 330 degrees is. First of all, 330 degrees is going to end up in the fourth quadrant. So that's 330 degrees. If we drew a reference triangle, so our reference triangle takes us back to the x-axis. So this is our reference triangle. Our reference angle is this small angle right here. How much would that be? Well, it's almost enough to make it to 360. So basically, we're trying to figure out how much do we have left to go to 360. So what we would say is 360 degrees minus 330 degrees gives us our reference angle of 30 degrees. So in other words, the cosecant of 330 is similar to the cosecant of 30 degrees. So we want to figure out what that is first. All right, so in quadrant 4, what's going to happen? Well, first of all, we know that any point or any ordered pair in quadrant 4 is going to be first positive, then negative. So if I know that 30 degrees would normally have, let's see, 0, so 0, 30, 45, 60, 90. So if I know that 30 degrees would normally have a 3 first and then a 1, I'll put radical 3 over 2 and 1 over 2. So 30 degrees would be radical 3 over 2 and 1/2. For 330 degrees, what would that point look like? Well, we know that the x value is still going to be positive, but our y value is going to be negative. So we know cosecant is related to the sine. So let's figure out what the sine of 330 degrees is. So the sine of 330 degrees from what we have here is negative 1/2. So how would we use that to find the cosecant? Remember that if we have a fraction for the sine, just flip it to get the cosecant. So it's basically negative 2 over 1 or negative 2 to get the cosecant of 330 degrees. So here's another one that we can try. So if you feel like you can do this, pause the video and try it yourself. So we need to figure out, first of all, what the ordered pair is at 5 pi over 6, hopefully without looking at the unit circle. And we also need to figure out what the ordered pair is for 7 pi over 4. So this time everything is in radians. So if we go back to the unit circle, one of the things that you'll see is that these angles, these special angles, 0, 30, 45, 60, and 90, that if we looked at the radian version of it, would be 0, pi over 6, pi over 4, pi over 3, pi over 2. So in radians, again, it's 0, pi over 6, pi over 4, pi over 3, pi over 2. So 5 pi over 6, you can check it yourself. Basically, the reference angles are going to have the same denominator. So 5 pi over 6 shares a reference angle with pi over 6. And similarly, 7 pi over 4 would share a reference angle with pi over 4. So we just need to figure out what the ordered pairs are for pi over 6 and pi over 4. So here's what pi over 6 would look like. So again, 0, pi over 6, pi over 4, pi over 3, pi over 2. Okay, I'm tired of saying pi over, so let's just say it this way. So 0, 6, 4, 3, 2. 0, 6, 4, 3, 2. So if we're doing pi over 6, so that's 6, notice that we have 3 first and then 1. So we're going to put square root of 3 over 2, and then we're going to put 1/2. So it'll be square root of 3 over 2, and then 1/2. So that's what we have for pi over 6. For pi over 4, we have 0, 6, 4, 3, 2. So again, 0, 6, 4, 3, 2. 0, 6, 4, 3, 2. So we fold down the forefinger for pi over 4. We have 2 and 2, so that's going to be radical 2 over 2 and radical 2 over 2. So let's write that down. All right, radical 2 over 2 and radical 2 over 2. So that's what we have for pi over 4. So now let's think about the angles. Where are they? 5 pi over 6 falls here in this quadrant. So this is where 5 pi over 6 is. 7 pi over 4 falls in this quadrant. So how do we use that to our advantage? Well, if we're in quadrant 2, remember how the points go. In quadrant 2, it's negative first, then positive. In quadrant 4, where 7 pi over 4 is, it's positive first and then negative. So if we write our answers down, remember pi over 6, we had radical 3 over 2 first, so it's going to be negative radical 3 over 2 from the value we have here, comma, positive 1/2, again from the value that we have here for pi over 6. For 7 pi over 4, remember our reference angle was here for pi over 4, we're using those numbers. So it's going to be a positive radical 2 over 2, and then a negative radical 2 over 2. So what does that mean? It means that the cosine of 5 pi over 6 is negative radical 3 over 2. The sine of 5 pi over 6 is 1/2. Also, the cosine of 7 pi over 4 is radical 2 over 2, and the sine of 7 pi over 4 is negative radical 2 over 2. So let's put that all together. In the problem we have here, it says we have the sine of 5 pi over 6 first. We know that the sine of 5 pi over 6 is 1/2, so we're going to put 1/2 first. Then we're multiplying that with the cosine of 7 pi over 4. The cosine of 7 pi over 4 is radical 2 over 2. So we're going to multiply by radical 2 over 2. Then it says that we need to add. So we're going to add the cosine of 5 pi over 6. So the cosine of 5 pi over 6, we just found out, is negative radical 3 over 2. So negative radical 3 over 2. And then finally, we need to multiply that by the sine of 7 pi over 4. So again, the sine of 7 pi over 4 is here. So we're going to multiply that by negative radical 2 over 2. The rest of this work is basically just going to be us multiplying and adding. When we do this part, 1 times radical 2 is radical 2, and 2 times 2 is 4. When we do this part, a negative times a negative is a positive, and 3 times 2 is 6, so that's going to be radical 6 over 4. One mistake, a common mistake that people make sometimes is radical 2 plus radical 6. They'll want to write radical 8. This is wrong. So we can't actually add under a radical. We can multiply under a radical, we can divide under a radical, but no addition. So all we can do is just say the denominator is 4, and then we are adding the numerators. So our final answer, I know there's a lot of work on here. If you need to, go back, replay this a couple of times, but our final answer is radical 2 plus radical 6 over 4. This problem looks like a monster. Like, how are you going to handle this? But just take it one piece at a time, substitute, and go step by step. Pause it, try it yourself, but we're going to talk about it. Okay, so for 4 pi over 3, remember how the fingers go. For 4 pi over 3, we're saying that it's going to have a reference angle of pi over 3. And for 3 pi over 4, it's going to have a reference angle of pi over 4. So the denominators are the same in the reference angles. And the reference angles go back to those special angles we're using in the first quadrant. So for 4 pi over 3, again, we're using pi over 3. So remember, pi over 3 is 0, 6, 4, 3, 2. 0, 6, 4, 3, 2. So 0, 6, 4, 3. We're going to have 1 first, then 3. So we're going to have 1/2 and then square root of 3 over 2. So we're going to have, as an ordered pair here, for pi over 3, we're going to have 1/2 and square root of 3 over 2. For pi over 4, we're going to have, so let's see, 0, 4, it's late. So we're going to have 0, 6, 4, 3, 2. 0, 6, 4, 3, 2. 0, 6, 4, 3, 2. So if we fold down the forefinger, that's going to be 2 and 2. So it's radical 2 over 2 and radical 2 over 2. So radical 2 over 2 and radical 2 over 2. Think about what quadrants these angles are in. So 4 pi over 3 is in the third quadrant. And 3 pi over 4 is in the second quadrant. So how do the points go? Well, if we're in the second quadrant, remember that it's negative first, then positive. If we're in the third quadrant, it's negative first and then negative second. So we would use that to write our point, to rewrite our point the following way. So we're going to say that 4 pi over 3 would have negative 1/2 and negative radical 3 over 2 as its point on the unit circle. Whereas 3 pi over 4 would have negative radical 2 over 2 and positive radical 2 over 2 for its point. So what would that tell us? That would tell us that the cosine of 4 pi over 3 is negative 1/2. The sine of 4 pi over 3 is going to be negative radical 3 over 2. The cosine of 3 pi over 4 is going to be negative radical 2 over 2. The sine of 3 pi over 4 is just going to be radical 2 over 2. So we're just going to fill these in. Oh, I forgot something. Again, it's late when I'm making this, so excuse the mistakes. So we know we're dealing with tangent here. Tangent is sine divided by cosine. So if we took, as an example, a sine value of radical 3 over 2 and divided it by 1/2, you can check it yourself, but the denominators will cancel, and that's just going to leave radical 3 over 1. So in other words, that tells us that the tangent of 4 pi over 3 is just radical 3 over 1, which is just radical 3. The tangent of 3 pi over 4, we're going to have to do the same problem, divide the sine by the cosine. So keep in mind that the sine is radical 2 over 2. And we're dividing it by the cosine, which is negative radical 2 over 2. Doesn't matter what these are. This is the same. This is the same. When we divide two numbers that are the same, what do we get? We get 1. Of course, because the signs are different, because we're dividing a positive and a negative, we're going to get a negative, so it's actually negative 1. So let's fill that in. So just to recap, we got for the tangent of 4 pi over 3, we got radical 3. And for the tangent of 3 pi over 4, we got negative 1. So if we fill that in, what will that look like? Well, tangent of 4 pi over 3, we said was radical 3. Tangent of 3 pi over 4, we said was negative 1. Then in the denominator, we have 1 minus, again, the tangent of 4 pi over 3 was radical 3. We're multiplying that with the tangent of 3 pi over 4, which is negative 1. So let's just work this out. We can't do anything with the numerator. Let's just leave it as radical 3. Let's see, plus and negative, might as well just write minus 1. And when we multiply negative times a negative, it's a positive. So the denominator is going to look like 1 plus square root of 3. There's not really much we can do with this, much else we can do with this. So we're going to say that this is our final answer. After watching all these math problems, I know you guys are probably as tired as I am. But anyway, let's say that we had 2 pi over 3. So what is the reference angle for 2 pi over 3? Remember, we're relating these all back to quadrant 1 angles, and the denominators are the same. So basically, pi over 3 is what we're relating it back to. So if we did our hand gesture here, so 0, 6, 4, 3, 2. 0, 6, 4, 3, 2. So 0, 6, 4, 3. We're going to fold the 3 finger down. So that means that we would have 1 first, then 3. So if we wrote that as an ordered pair, that's going to mean we're going to have 1/2, and then we're going to have radical 3 over 2. Think about where 2 pi over 3 is on the unit circle. 2 pi over 3 falls into the second quadrant. So because it falls into the second quadrant, how would the points go? All points in the second quadrant are going to be negative first, then positive. So when we write down our actual value for 2 pi over 3, it's going to be negative 1/2 and positive radical 3 over 2. So what does that mean? Well, it means that the cosine of 2 pi over 3 is negative 1/2, and that the sine of 2 pi over 3, let's try that again. So the sine of 2 pi over 3 is going to be a positive radical 3 over 2. So let's suppose that we substituted those values. So again, cosine of 2 pi over 3 is 1/2. So the first part of this problem says whatever we input squared. So cosine of 2 pi over 3 is, we said, was negative 1/2. So it's negative 1/2 squared. We're then going to add, again, the second part says whatever we input, we're squaring it. So we have sine of 2 pi over 3 is basically radical 3 over 2. So if we square it, what's 1/2 times itself? 1/2 times 1/2 is 1/4. So 1 times 1 is 1, 2 times 2 is 4. And then if you square a square root, so a common misconception students have, how do you do this? It basically means you're multiplying that square root times itself. So that's square root of 9, or basically 3. So to make a long story short, I know I say that a lot in class particularly, but square root of 3 squared is just going to be 3. The square and the square root cancel each other out. Anyway, so square root of 3 squared, that's just going to be 3. 2 squared, that's 4. So we just need to add this. Looked like a hard problem at first, but this is all just going to be 4 over 4, and that's 1. If you're an especially advanced student, you might recognize this identity, but we've just seen a specific example of why this identity is going to lead to 1. But in any case, I hope you guys enjoyed the math problems and enjoy the other math problems you're going to have to do that these are examples for. But thanks for watching.